Diverging lenses are tricky too. There's our principal axis. Here's our lens. Right now, we don't need to draw this, but just to help us see it this time, here's our diverging lens. Now, one of the weird things about diverging lenses is the focal lengths are sort of, quote, on the wrong side. They're back behind. And what that means is when we work with them mathematically, that the focal length will be a negative number. In this case, when we're just drawing pictures, it doesn't really matter. Here's our object. Now, this is a diverging lens, and you got to keep that in mind. If the light comes in parallel, it does sort of go through a focal point, but not this one. It acts as if it bent and came from the focal point that's behind it. So it goes away. That's what classified it as diverging. And the other ray that's easiest to draw is if it goes straight through the center of the lens, and you're like, dang, those two rays are clearly not going to meet, so you have no real image. But if here's your eye, big eye, eyebrow, eyelashes, your brain sees this ray and this ray coming in straight lines and thinks, I know light only travels in straight lines, so therefore I can totally tell that this beam of light must have come from here. And this beam of light actually did come from here. But your brain sees them starting together at this spot. It can never see the actual image, actual object. It sees this teeny tiny, right side up, virtual image.